Hello there and welcome. In this video we will solve problem number 2 from 2013 AP Calculus BC free response questions exam. And the graphing calculator is required for this problem, so we will use it to a large extent. And what we are given here is two curves in a polar system. One is r equals 3, it's this circle. And then another one is r equals 4 minus 2 sine theta, which is this other curve here. And we are also told that theta equals pi over 6 and theta equals 5 pi over 6 are 2 points at which they intersect. And so the first question is to find the area, the shaded area. So what I've done here is I drew some lines. The first line corresponds to theta equals pi over 6. The second line corresponds to theta equals 5 pi over 6. And then the third line corresponds to theta equals to 0 and theta equals to 2 pi. It's the same line. And so first let's recall what is the formula for the area under the curve given by in the polar system of coordinates. So the area between the angles theta 1 and theta 2 is given by the formula 1/2 r squared, and r is given as a function of theta, d theta. And this is theta 1 to theta 2. So in our case, we have three integrals that we need to add to find the entire area. So the first integral is for theta between 0 and pi over 6. And in this case, it's 1/2 r squared, where r is equal to 3. So this is this r and this area correspondingly. Plus the second integral, which is integral from pi over 6 to 5 pi over 6. And in this case, 1/2 r squared d theta, where r is given by this function 4 minus 2 sine theta. And this is the area that we find in this second case, second integral. And then finally, the third integral is integral from 5 pi over 6 to 2 pi. And again, in this case, it's 1/2 r squared, where r is equal to 3. And so this is the third area here. This entire area is given by the third integral. So let's use our calculators to calculate the sum of the three integrals. And I have it here on my right hand side. So let's go mathematics, integral from 0 to pi over 6, function 1/2 times 3 squared d theta, that's the first integral, plus the second integral, mathematics, integral from pi over 6 to 5 pi over 6 of the function. In this case, it's 1/2 times 4 minus 2 sine theta squared, again d theta, plus the third integral from 5 pi over 6 to 2 pi, and again it's 1/2 times 3 squared d theta. Enter, and we find the value of this integral. It's 24.71, so this is equal to 24.71. And so this is our answer for the value for this area. Let's look now at part B of this question. A particle moves along the polar curve r equals 4 minus 2 sine theta, so that at time t seconds theta equals t squared. So we have a new variable t here. Find the time for which the x-coordinate of the particle position is -1. So what I drew here is the beginning position of the particle. It's at point x equals 4 and y equals 0 right here. And then the particle moves along this line as t increases. And so at some point its x coordinate will be -1, and so we need to find this time t. Note that the answer here is not unique, because as particle moves along this curve, at some point it reaches this point here, which also has x-coordinate of -1. And then as it continues to move, it will make the full curve, the entire curve, and then it reaches again the same point. So the time is not unique. But given that we have t is between 1 and 2, we have a unique solution here. So let's find that solution. First, let's recall that x-coordinate is given by the following function, r cosine theta. And so plugging in the values for r and theta in terms of t, we get that x is equal to 4 minus 2 sine t squared times cosine t squared. So this is x-coordinate at time t. And so we need to find such t that this is equal to -1. Let's add +1 to both sides, because our calculator requires us to, our solver in the calculator requires us to enter this function on the left, and then we can solve for t. So let's solve for t. Let's go to our calculator, mathematics, solver, equation, and the equation is given by, before we go there, let's change theta to t. So let's go to mode, parameters, enter, second quit, mathematics, solver, and so the equation is 4 minus 2 sine t squared, close parentheses, times cosine of t squared plus 1. So we need to solve this equation, find such t that this equation is true. And so let's guess a particular value of t. Let's say t is equal to 1.5, which is the middle of our interval between 1 and 2. And so let's solve this. We get 1.43. So the answer is, at time t equals 1.43, t equals 1.43, the x-coordinate will be equal to -1. So this is our answer to this question. Let's look at question C. For the particle described in part B, find the position vector and find the velocity vector at time t equals 1.5. So let's do that. Let's first find the position vector. And the position vector, let's denote it by S, is equal to the x and y coordinate of this vector, which is equal to r cosine theta, comma r sine theta. And so let's plug in all the values in terms of t. What do we get? We get the x coordinate is 4 minus 2 sine t squared times cosine t squared, comma y coordinate is 4 minus 2 sine t squared times sine of t squared. So this is our expression for the position vector in terms of t. To find the velocity at a point t equals 1.5, we need to numerically integrate this position vector. So differentiate. We need to differentiate the x coordinate and the y coordinate. And in this case we get, let's use our calculators, and we have quit mathematics derivatives with respect to t of the function 4 minus 2 sine t squared times cosine t squared at the point t equals 1/2. That gives us negative 8.07. And then for the y coordinate of the vector v, we do again mathematics derivative with respect to t of the function 4 minus 2 sine t squared times sine of t squared at the point t equals 1.5. And so our answer is here negative 8.07 and negative 1.67. So this is our final answer. If you have any questions or comments, please don't hesitate to contact me. My contact information can be found here on my website. And thank you for watching, and I hope to see you in the next video.